Thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at the new SAT math test. My name is Mike Houston, and I'm moderating tonight's event. I'm excited to be joined by our two panelists, Jeff McCullough and Tom Reardon, both who have just a lot of experience, not only in teaching mathematics, but also in the ACT realm as well. So I'm excited to have those two guys with us tonight. Jeff, can you tell us what we're going to expect to be able to do tonight?
Sure thing. By the way, it's great having this many folks here. We're excited about this. We're going to address the changes, and there's been some whopping changes that some students just took the enhanced ACT test for the first time just this last month. We're going to talk about basic, if you're new to the ACT world, what kind of basic calculator techniques do you need to solve some of these problems? We're also going to tackle some really tough ones by graphing or using the table, even using some inverse functions. And Tom's going to show a number of things, but one of the things is many activities that pack a punch. Tom, do they punch? Do they have a little punch to them?
Oh, Tom, you're muted.
You're muted.
Oh, I hope they do. I do hope they do. We'll see.
Okay. And we also have a webinar drawing coming up as well. So that's fun.
Thanks, Jeff. So tonight, many of you have already realized we're going to use that chat window to send general messages. If I had to guess, Tom's probably going to ask you pretty soon to use that chat window. And so have that handy. Mine's on the right side of your screen. If you have any questions for Tom or Jeff, again, use that chat window. See if we can get maybe your questions answered live tonight. As a reminder, the session is being recorded and we'll provide links to the event certificate of attendance as well as links for the documents at the end of the webinar. Jeff, it's all yours.
All right.
Hey, Jeff,
Yeah.
before we start, could we find out in the chat, and I'll look at it, I'll keep track, who has what calculator?
Oh, that's a great idea. So if you have
So if you have an 84, type a 1 in the chat. If you are good at Nspire, feel comfortable with Nspire, 2, and if you're comfortable with both, 3. So 1, 84, comfortable, you're more comfortable with, 2, Nspire, and 3, both. And Jeff, go ahead, take it away. I'll count them up.
Okay.
Thanks.
Sure. Okay, so we want to talk about the new ACT, and in my kids, a lot of mine took the new enhanced one. The October one was well, I guess it's September. The September one was the new enhanced ACT for pretty much everyone. And I know one thing, like the main one, I think was J01 was the kind of name of it. But there were J02, J03, J04, J05. There were a lot of different versions. I think that messed with students a little bit. And they said, and you hear this as math teachers, they said the ACT math section was especially difficult on some of those. So I don't know if y'all heard similar things from students, but I don't always hear the math section was especially difficult, but I did this time. And that, we don't know what that means. We don't know what was on there. That hasn't been released yet that I know of. So, but this is some of the changes that we're seeing. The content itself is not so much changing as much as just how many questions of each. And so you can see, a lot of these categories, pretty similar amounts of questions on the old test and the new test. Even though there were 60 questions and now there's only 45. So there's less questions by 15. A lot of those they took out were, you can see this category. So middle school math, a lot less questions about middle school math, percents, ratios, basic geometry, almost like pre-algebra stuff there. Less of that. You still have some questions, but not nearly as much. And you have less modeling questions. So you went from 16 to about 9 or so. And so it should be a little bit more streamlined. In theory, you should be able to finish faster. Tom, what do you think about some of these changes they made?
Sorry, I was counting. I like the fact that they have more time. I do like that. That's probably my main thing. I think it is going to be harder because, like you said, there's fewer middle school questions on it. Um, but I do like the time.
Yeah, and Tom, I don't know if you want to put that bit.ly in the chat window, but I know Tom has a bit.ly that has all the documents we're going to be using today, including this one. And so that at some point he'll put it in the chat window for you. But yeah, it went from 1 minute per question to 1 minute and 7 seconds, so per on average per question. And I think this should streamline it a little bit, like 5 answer choices went to 4. Um, Interestingly, it's not all digital, so you still have the option. A lot of my students prefer to paper test, and so they took it on paper, and that's okay. Um, Again, just the big thing is they took away a bunch of those questions. If I had to summarize, I'd say they took away a lot of the medium difficult questions, a lot of the ones that were listed from kind of 15 to 45. A lot of those kind of disappeared. And so they kept a lot of the hard ones and some of the easy ones as well, but a lot of meaty ones disappeared. Uh, Tom, you ready to get right into this?
Yeah, I am all for you.
What did you find out about 84s and TI-Nspires? Anything?
Right now, we have one person that uses Inspire.
Okay.
Everybody else is either 84 or both.
Okay. We'll still mention Inspire and do some stuff, I'm sure. Okay, so this first one, structure, and this is kind of new. I know, Tom, we worked on the SAT, and the SAT loves structure problems, but this has been popping up on the ACT as well. And of course, you can kind of solve this, if you kind of piece this together, and you see that kind of factor out the GCF there. Um, you can then replace A minus B is really 5 and just plug it in and get your answer there if you want to do it that way and if you see it. But I don't know how many of our students, Tom, would solve this. It's a little unusual. Usually we're used to solving for A and B. What is A? What is B? And we don't really know in this case. What do you think?
Yeah, this is one of the ones I think kids would look at right away and say, well, I'll put that aside till next time. They see more than one variable in there, and then
Yeah.
they usually might not even try it. And it's so much easier than you would think.
Yeah. Um, and this isn't really a calculator method here, but I really like when students have what I call kind of a plug-in mindset or substitute mindset where they're going to plug in numbers. So if you take this equation, A minus B equals 5. And Tom, would you just choose for me 2 values for A and B that make that equation true?
8 and 3.
8 and 3. So 8 minus 3 truly is 5. So now if we write this as C equals 7 times 8, minus 9 minus 7 times 3, that will also give us the right answer, right? So, and it didn't matter if you'd chosen, 7 and 2 or 6 and 1, all those would work. And that's kind of a nifty workaround that a lot of math teachers might not think of, but we need to show our students something like this because this also, I think both of these can be eye-opening, showing them the structure of the problem and then also kind of showing, hey, you could just plug in numbers and it might work that way as well. Let's look at the next one. And, Tom, this looks to me almost like a tough algebra 2 problem or maybe a pre-cal problem. How do you think students are going to approach this one, do you think?
This might be another one they might want to pass on, but let's hope they don't. And I have to get a common denominator, and so I'm hoping they'll factor the denominator in the second
Okay,
rational expression.
sure. And so we get, something like this, and we get 4 times y plus 1. And so you can do 4 over here and 4 over here. And I don't know why I didn't see this. I guess I'm just trained to, distribute up top, kind of combine like terms up top and kind of solve the problem. But Tom, how much does anyone see in the chat window? Do you see anything there that kind of a shortcut? What do you think, Tom? Anyone in the chat window see it?
Um, Nothing yet. No. Okay, now I'm starting to see it. Yes. So somebody saw parentheses 4 minus 2 times the quantity y minus 1. So if they saw that it was 4 of those parentheses minus 2 of those parentheses, which would be 2 of those parentheses.
So this is also a structured problem in a way, isn't it? Because
Yeah.
yeah, so it's really 4 y minus 1s minus 2 y minus 1s. That's 2 y minus 1s. Wow, that was fast. And then I guess just cancel that, right?
Mm-hmm.
You got it. Which is really nice. Now, our students, again, some of our students, one thing I notice, I tutor a lot, and some of our students who are even, in pretty good math classes, they're in pre-cal, and they really don't like algebra. They don't think in algebra terms, maybe I should say. They're not what you would call algebra folks. And so this is a really tough problem for a lot of our students, or maybe their algebra is not good enough to get a common, denominator right there. So I think there's a way to do this on our calculator. So let's go to the TI-84. Tom, how much you consider doing this in the calculator? What would you think about doing?
I could put in a value for y, type in
Yeah.
the original, and then type in the answers and see which ones are equivalent.
Yeah, so I'm going to store a value. So you type in 3, and then the stow key is right above the on key. It looks like a little arrow when you hit it. And you can store for y. So I'm going to hit alpha 1, which is the alphabet letter Y there, and press enter. And now every time I hit alpha 1, which is Y, it's going to think I typed 3. And so now you can type this in just like that. So it'd be Y, so alpha Y. I think the drawback of this method, it does take a time to do it, but doing the algebra takes a little bit of time anyway. If you didn't see that shortcut, that would have taken quite a while, I think.
And another thing you might consider, instead of using y's, using x's, just because it would be quicker to get an x.
That's
You know
an
what I mean?
excellent point. Now that I'm halfway through,
Yeah.
I see the wisdom that your age has brung, I think, in this one, Tom.
Oh, thanks. Yeah, yeah. Supposedly I have wisdom. Yeah.
I mean, it brought you something, I think, right? I don't know. So y plus 4. Okay, so let's try this. So this gives me 1/4, and I like glancing at those answers. So right away I can see that it's not one of those guys. And so y is still stored that way. So if I type in C, I should be able to see if that one's equivalent or not. So alpha y minus 1 over 3. And I do think it's worth it. If you know you're going to get it right, I think it's worth it to do this kind of thing on a problem 48. A lot of students are not going to be able to get a problem 48, and this guarantees you get it right for a student and so 1/6, that's not right. I won't even plug in D. I just choose D and move on. I like teaching students to be analytical thinkers and cross out those bad answers. I really like students doing it that way. What do you think, Tom, about that?
Yeah, I do. Somebody, I just saw a real quick chat pop up, and someone said to graph them, like
Okay.
instead, like if you graph the original one,
Yeah.
and and see if it's equivalent to the graph of A, B, C, or D. I don't think we should do that now. I think it would be a long time in doing it, but I
Yeah.
think that's an excellent way of visualizing.
Oh, and by the way, Tom, that would make you happy. If I had to graph this, I would have to use X's, right?
Yeah.
Because it doesn't graph if you put in a bunch of Y stuff there. So that would be another way for sure. And I definitely have some teachers that teach that. If you teach graphing a lot in your classrooms, you can graph so much stuff to solve some of these tough ones. So I really like that idea of graphing that guy and graphing this one, and they should be right on top of each other, right? And you can even look at the table and see that all the values are the same. So I really like that move. That's a good one. Sometimes we're surprised by questions. I haven't seen a lot of this on the ACT. This was on one of the more recent tests here in December. And so well, they didn't say, they said, I guess you could do long division, right?
Yeah.
Would you have to be crazy there, or what do you think? I think this is the only American math that I know of. I think other countries would probably use long division. They don't have, did you know that, Tom? I don't think they have synthetic division in other countries.
Really?
I think that's true. I've talked to some friends overseas, and they're
Oh,
like,
hey,
what are you
hey,
talking about?
don't forget your 0 for the x to the 5th,
Thank you.
and the
So
0 for the x squared too.
right after here, right there.
Yeah, and then right after 2x cubed too.
I should really start paying attention here. Okay, so 1, and then I get 1, and that's 0, and 0, 0, 0, negative 2.
Answer to Martha, yes. Calculator allowed on all of it.
Yeah, and 0, 0, 0, 1, 1, 0. So we get, wow, so this is what we get. It's kind of an unusual thing, but what's a remainder? It's 0. And I really like the idea of, like, if you know the remainder theorem, if you actually know a little math, it might have been easier to plug in 1 into the equation. Like, what is f of 1,
Oh,
essentially?
yeah. Yeah.
So you could almost do that in your head. I just want to mention Inspire because I really like the other version. Like, you could, of course, store this like we just did on the 84, but on Inspire, it has a really cool feature here. I like it for plugging stuff in. I think it's one of those building blocks on Inspire that you have to know. So I'm just going to show it here. So you type in the whole expression plus 2x to the third plus x minus 1. And if you put the such that bar, which is control equals, you get this control equals, and we're going to say x equals 1, and it plugs it in, and that's essentially the remainder. Plugging 1 this value should always match that according to the remainder theorem. So knowing a little math could really help you here. Tom, I thought this was fascinating for a number of reasons. I really like the solve command on 84. If you haven't tried it in a while, let me get to 84 here. So if you haven't tried it, it's the math key, and no math teacher wants you to know where it is, so they hide it at the bottom of the menu. It's math and up arrow 1 to numeric solver. And if you put this one in there, I'm going to use x. I'm going to use Tom's trick of just using x here, x squared plus x plus 3. That's the E1 is your left-hand side. Then E2 is your right-hand side here. Whoops, let me clear that off. And then hit OK, and then you can put a guess there. I'm just going to guess 10, I guess, and guess, and it says no sign change. It doesn't solve it. Tom, why did it give me this error here? What do you think?
Probably a non-real solution. So maybe your mode, you might be in real mode.
So, I mean, yeah, if the graph, it didn't really, kind of have any solutions there on the axis. So maybe that's it. So maybe I'll change the mode. Okay, let's try that. I like that idea. Whoops. Okay, let's see. A plus BI. Okay, I put it into A plus BI mode. I'm going to go back to math up arrow. I'm going to hit graph twice. Same thing. So I wasn't sure, but I don't think it solves imaginary. It doesn't give, so I know it's not a real, or it would have given us the answer there. So it must be one of these imaginaries. I don't think the equation solver works on that.
Okay.
And I thought that was interesting for math teachers to know. Maybe you thought it would work. On a CAS machine, so on TI-Nspire CAS, it does work. But a non-CAS machine, it doesn't work. And so let's try plugging in values here, because we can, even if it's not in real mode, we can plug in a value like 2i here. So we can store 2i. So 2, and then to get a decimal, to get I, you hit second decimal. And 2i, we're going to store that as x. And then type in our quadratic here. So x squared plus x plus 3. And when we plug it in, that's definitely not 0, what we wanted. So we know that one's wrong. Again, you can store pretty quickly. I don't think I want to store this. It's going to take too much time, but I know it's not real because I tried it there. We could also, restore. The thing I like about store is you can store -1, stow as X, and then copy and paste. And again, you get that. And Tom, I took liberties with your method. Tom, do you want to explain your method of the y equals what you like to do with quadratic formula sometimes?
Actually, it's going to be part of what I'm going to do. So
Okay.
if we could just hold off.
Okay.
How about if we
You're
do?
gonna
Is that
do
okay?
that. Oh, that's great. So we'll let you do that. So
Yeah.
that's excellent. Tom has a really nifty trick that he uses here. And this is really true here. Again, kind of like we did on that other problem, we said you could graph it. Domain can be tough for our students. If you know what you're doing here, it's not too bad. You say x minus 3. Normally, the radicand is set greater than or equal to 0 because it's in the denominator. I would just probably say greater than 0, and the answer is here. But a lot of my students might have trouble with this one. And so I think when you get to a tough problem, you're not sure how to do it, graphing it really helps us kind of solve some of those problems. So let's try graphing this and see what happens here. So square root of x minus 3. If you graph that, it looks like that. I can't tell, Tom, if there's other parts to that graph. So I'm going to hit trace. And it looks like I'm going to the right here. When x gets bigger than 3, I see the graph. I see it. But when x is smaller than 3, it's got nothing there for y. So I don't think that's there. And I really like looking at the table. Tom, did you teach your students how to use the table a lot? Do you like using the table for this?
I love the table, and I even think maybe even graph table at the same time.
So if you haven't seen that, so mode, if you go down to, even on the old calculators, it used to have GT mode on the 83. So it's been around, but it's called graph table now. And so if I hit, I'm going to hit second table, and I can control this. Oh, that's so nice. Isn't that nice? So that's, I'm glad. So Tom, and isn't it better you could hit graph, but you get some weird values when you start tracing, right?
Yeah, go ahead and press trace. Let's show them what happens.
Yeah, trace. Oh my goodness, that's messy, isn't it?
Yeah, nobody's happy. So the idea is to say second graph to be in the table, and
Oh,
and then you can, yeah, that's I love that.
that's so nice. And you can just see when it reaches 3, it's just an error. It's undefined. This calculator says error. I think the TI-Nspire says undefined when you do that on Inspire. By the way, for each of these questions, I think Tom did this too. I wrote the answers out on a PDF. 84 and Nspire here. So for each one, I showed screenshots and so forth. So I showed some of the screenshots and things for each one of those. And so that's part of the documents you're going to get here when you do this. And Tom, are you doing this one when you have functions and graphing?
No.
Okay. I really like this guy. I'm going to change the mode back to full here. So I guess I don't have to. So let's go to y equals. And so for this one, you're going to define the first function as y1. So instead of f of x, we're really using y1 there. So I'm going to say 4x plus 12. And then for the second function is g of x, and we're going to call that 1 over x. So 1 over x. And the third function, we're going to compose the two. So we're going to graph the composition of the functions. Let's just look at what those look like. So there you go. You can see one of them's linear. The first one's linear. The second one is, reciprocal function there. And Tom, I'm going to do this. I'm going to turn off those two graphs by clicking the equal sign.
How do you turn them off? I'm sorry.
So I click the equal sign. So if they're on, it's always bolded like that.
Oh,
If
okay.
you click it, it turns off. And so now it's not going to graph 1 and 2, but they're still there. And so because, again, this is our Y1 is F1, Y2 is this one. When it says G of F of X here, that's really Y2 of Y1 of X. So I'm just going to graph that guy here. So, so to get to that, you hit alpha trace, where you go Y2 parentheses Y1 parentheses X, and close those parentheses. I like to close parentheses just for our students. Zoom 6 is how I tell my students to graph on the 84, and you can see it's right there. You can probably tell it's at -3, but I really like using trace. You can type the number -3 in trace mode. Oops, -3. And it says the Y value is not there. It's undefined. Again, you can look at the table and you can see at -3, it says error right there. So really easy to see that -3 is not a solution there. Of course, you can always do this by hand. I'm just giving you ways. This is problem number 54 on the test. And our students are struggling when they get to these higher number problems on the test here.
I agree you could do these algebraically, but I think being able to visualize them and see exactly why -3 doesn't work or what number doesn't work,
Yeah.
both graph and table is huge.
And this one, Tom, this will be my last problem. I'm about to hand it over to you, but this one was really fascinating to me. It's problem 58. I mean, it's a weird one. In
Ooh.
fact, I thought, is there anyone in the chat window that can solve this algebraically? Like, what are you going to do here? It says the Y value, the output is going to be a positive prime number. How often? What a strange little question here. Because you can plug in lots of different X values. So what kind of outputs could you have? My first thought was to graph it because I thought this one looks tough to me. So I'm going to type it in. So X. Anyone in the chat window know how to solve this algebraically? I really am curious.
One person said, wouldn't one of them have to be a factor 1?
Oh.
So that would make it 2 and 5.
Wait,
Go
what do
ahead.
you mean a factor of 1?
It means X minus 1 would have to be 1, or X minus 4 would have to be 1. Because it'd be 1 times the number to get you a prime.
Oh, if you multiply, then either X minus 1, I like that. X minus 1 must equal 1, or X minus 4 must equal 1, because what is the definition of a prime number? Only divisible by 1 and itself. So therefore, X could be
So Jesse,
2
thank you.
or 5, right? And so if X is 2, what do you get? You get -2, which is not prime. If X is 5, you get 4, which is not prime. So I think the answer has to be 0. Oh, that's really beautiful thinking. I was first thinking, I don't know why, I was thinking one of those would have to be even, and then one would have to be odd. Yeah, not necessarily knowing which one, but then I would get an even result, if that makes sense. But I like that so much better. Oh, that's good. I'm glad someone thought of that. That's cool. And I wasn't actually thinking the graph. I actually think the table here.
Yeah, I just went to the table, and you could actually flip through the table and look for prime numbers.
Yeah, I mean, pretty quickly, you can see they're all even. 2's not one of the answers there, so I think you got to go. They're all even. There's no 2. It's got to be that one. But I thought it was a fascinating question, and I thought using the graph or the table there was a really cool use of being able to plug in a lot of answers very quickly. I think tables underutilized by our students for sure. Okay, Tom, by the way, again, we're going to have all these problems available with screenshots for you, with TI-84 and Nspire versions here. So for these guys. So I would, Tom, can you take the thing and you take over here?
Oh, yes.
That would be great. 'Cause I'm excited to see what you got, what you have to share. And by
So,
the way, uh, if you're wondering, because Tom did that, it was like positive peer pressure that I felt like I needed to put all the answers in there because that's a little over and above for me. So Tom really, he spurs you on to do a little better sometimes.
so where are we? Here we go. All right, so you can see that okay, Jeff?
Yeah.
Okay, perfect. All right, so Jeff mentioned this before. All the materials that he gave are going to be on this website, and also my materials will be on this website. I think there'll be things that I'm not going to get to tonight that you're definitely welcome to use, okay? So it's bit.ly/T3ACT 2025, all lowercase, okay? And I think Mike might have put that into the chat also. So, and I'll put it back up, but I will warn you though, on Jeff's, you can just click on it and the PDF will show up. On mine, they're zip fold files. So you have to download the zip folder and then extract it. Okay, so just be aware of that. If you try to just open up the PDFs as where they are, you might have some problems. So, all right, so I'm going to come from another standpoint. I'm going to look at, instead of individual problems, which I normally would do, I have created a few activities, what I call mini activities, that address what I think address ACT questions. And this first one came up because I've probably done, I mean, between Jeff and I, how many thousands of problems have we done in the last
Oh
few
man,
years?
I don't even know.
Just to help, because we've written the PD for T cubed and TI, so we wanted to make sure we had good problems. But anyway, on this one here, let me show you why this one we thought this was worthwhile. So it's the ball is thrown vertically from the edge of a cliff that overlooks the ocean while the ball is in flight. The height of the ball above the ocean is given by this formula. And these are the questions that could be asked. Okay, one of them could be, what's the initial height of the ball? What's the height of the ball exactly 2 seconds after it was released? Is it ascending or descending? What about 7.23 seconds? When is it 500 feet above the ocean? When does it reach its maximum height? What is its maximum height? When does it hit the ocean? Where is the height of the ball 1 second before it hits the ocean? So these are all questions individually that could be on an ACT. But I'm thinking, why don't we just do them all at once and have the kids be able to discriminate, when do you use this? When do I use that? And so on. So I created this, you have it, and you'll have all the solutions. So let me just kind of go through and show you what I think here about this. So this one right here, ball, this is the problem. And I asked them to round to the nearest thousandth. So
Sounds
let me
like a
go.
calculus teacher right there.
What's that?
Sounds like you taught calculus before.
Yeah, I did. Yeah, a little bit, a little bit. I used to do this a lot in pre-calculus and even some in algebra too,
Yeah.
to help prepare them. So anyway, I'm a big fan of using programs, as many of you know. So I wrote a program called Ball Throw. And what it does, and you don't have to have this, but what it does, it sets everything up in the calculator for you. Okay. So
Okay.
so I'm just going to follow the directions. These you have this PDF, so you'll be able to go step by step, and the kids can follow your lead or whatever. Okay, so step 0, I want the students to be able to visualize the problem. So to do that, we ran the program Ball Throw, and now what we're going to do is I'm going to go ahead and press graph, because what I did was I put in the equation into Y1, and I'll just say graph. I
Okay.
preset the window. Students who have to play around with that because that's not my focus here. Okay. And then I'll press trace. And what I would want to know is, I want to ask my students, what do those two numbers mean? I think it's very important they have an idea about what that is. And I hope they don't say, well, X is 7.5594. I would love it if they would just say, at 7.5 seconds, the ball is 594 feet above the ocean. Okay,
Okay.
that would be my love. I would love to hear that. Okay. So here's where this is another thing I want to get across. We need to have a discussion with the students. Many students think this is the flight of the ball. That's the equation.
Oh, yeah.
This is, when they shoot a ball like a basketball or hit a baseball, it's a parabola. We've got a parabola for the equation. Is that the flight of the ball? And I want to get to them. It is not. Okay. So what I've done is to help them get that, I'm going to have them change the mode from function to parametric. Now, some of you say, oh, my kids don't understand parametric. We haven't taught them that, or we don't teach it. I'm using this as a tool. Your students don't know how your calculator works, but they use it. And so we're going to use parametric equations here to help see that. Okay. So I've got parametrics on. Okay. Now, when you press y equals, look what you got. Now, some of you said,
Oh my goodness.
some of you are, yeah, some people are going, oh, I think it's broken. No, it's not broken. Okay. There's a reason for this. Okay. This is what I want. Okay. I already did the next steps where I set all this up. So I'm just going to skip this part. I'd already put that in the program. When I first did it, I did not. Now, before we do graph, I want you to realize there's going to be two graphs. The blue one is going to be height versus time. The brown one's going to be actual flight of the ball. And I'm going to make it so that it's simultaneously, or at least at the same time. Okay. So I'm going to go ahead and press graph. And in fact, let me make this big. So this is a big deal. Okay. So I'm going to go ahead and press graph.
Oh, that does help me understand.
Okay. So
that is neat.
The brown is the actual flight of the ball. That's where it's going. The blue is still height versus time. Okay. So to me, this is essential. And again, students don't have to understand parametrics. Just use it. Okay. Just use it as a tool.
All right. And Tom, I have to say, the ACT, they are asking so many more questions about the context. What's the y-intercept mean in the context of this problem? What's the x-intercept mean in the context? They're asking questions like that. And so this is great to show some of this. I really this conceptually, this is like what we want, right?
Right. Exactly. Oh. Exactly. And by the way, Nspire users, we only have a few, but I have the file for the Nspire users as well. Okay.
Oh, wow.
All right. So now I'm going to go ahead and press trace. And now again, you'll say, wait a minute, it's not just X and Y, there's this T thing going on. Okay. And you could ask them, what do you think the T and so are, but I'm hoping that they'll see is T is time in seconds. Okay. We'll go with an X well, that's what it is. Okay. So what does this mean right here? At time 0, what's going on? The height of the ball is that. Okay. Now, if I click on, just go 1 to the right, notice that if I just click once, it's going to go by 1/10 of a second. So this is telling me in 1/10 of a second, this is where the ball is, how high above the ocean. It's not traveling like this. It's still going straight up and down. Okay. By the way, I do have a little caveat. When it comes back down, it's going to miss the cliff because we were right on the edge of the cliff. It's going to definitely come down to the ocean. I have to cover that. Okay.
You probably could have restricted the range or something. I don't know. There might be a way, but.
Okay. So anyway, I would have them play. I'd say, just go look, go look someplace. And by the way, if you're in a hurry and you want to get to 2.5 seconds, just type in 2.5 and it'll say T will be that. And it'll tell you what the height would be. It's on its way up and so on. Okay. So I'm not going to do a whole lot.
Can you show us, just for fun, in the window setup, table setup, is that where you said the trace step is 0.1 there in table setup?
That is in...
or is that because it's parametric?
No, it's because it's parametric. And when I set the window, I set the T step in the window. See
Yeah,
here,
so
right
T
here.
step in the,
So T is your independent variable, and X and Y are now both dependent.
okay, so T step is 0.1. That's how I was what like how did you get it to trace to such nice values?
Right.
You
right.
set the T step,
Right.
right? Which
And-
we can also do with X if we want to. You know, you can change that
Right.
on a regular graph, I think. But that's neat. That's neat.
So now, say you wanted to do this again. If you go to press graph again, you're going to be disappointed because it's not going to do what you want. So here's a little trick. Go back to y equals, and what I usually do is I just go down to where it says 0, and I type 0 on top of 0, and it's telling the grapher, I just changed the equation. Please regraph differently,
Yeah.
but I didn't. So now when I press graph, I get the same thing, but I get it back. So that's a real quick way of regraphing, without doing a whole lot of work.
And so you didn't make that slow down. That just did it slow because it's parametric.
Yeah. I mean, the ball, notice as it's getting towards the top, it's slowing down, and it just, and what I love to say, especially in calculus, what does it do when it reaches its highest point? It stops instantaneously.
Oh, yeah.
Velocity is 0 right there. And you'll notice as it's coming back down, it gains speed. Okay. So all this stuff, more stuff there. So anyway, all right. So I have them play with this, but then it's now time to go ahead and answer the question. So I'm going to go back to function mode. And notice I did all this in the background so students don't have to worry about typing all that in.
Yeah.
It's all in that program. The Windows set, everything, because that's not my phone. That's not my, what I'm focused on right now. So now I'm going to go ahead and press graph. And what I'd like to do is explain to the students that this graph is not the graph of the problem situation. Because we don't really, right here, this part right here, this is before 0, before time 0. That's not happening. And when it hits the ground or hits the water, we don't really care what happens. We don't, about that. So we're really more interested in what we had with the parametrics, but we could talk about that. We can discuss it, but it's not a big deal. So now we're going to answer the questions. What's the initial height of the ball above the ocean? Okay. So I would go to trace. And I'd say, well, that would be, and a lot of kids don't know what initial is. If they haven't taken physics or whatever, they're not sure about that. So I'm just going to say that's at time 0. And this time X is time, Y is height. And so there's that 144 that we saw before when we did the parametrics. All right. So that's the first question. And that could be just one question on the ACT, and that would be it. Okay. Second question, what is the height of the ball? Exactly 2 seconds. Well, again, we're already in trace mode, so I'll just type the 2.
Yeah, I love that.
There's my answer. Okay. I could also go to the table. I could evaluate the function at 2, but hey, let's use the graph. They can see it. Okay. 3, what's the height of the ball? And here I just put that ridiculous number in here just because to tell you don't have to be like every 10th of a second or whatever.
Yeah.
You can type in any number, and it is descending. We can see that. Now here's the other one. After how many seconds is it 500 feet above the ocean? You're going to have some kids who want to type in 500. I mean, they just, that's just it. But here's a case where we have to say, no, we want to know the height when it's 500. So we'll go back to Y2 and graph that and see that there's 2 points of intersection.
Oh, yeah.
And so there's one on the way up and one on the way down. Okay. And then to do that, we'll go ahead and use the intersect tool. So that would be second trace for calculate, intersect. And first curve, blue, second one, red. Now my guess, if I go with this guess, I'm going to get the one closer to 7.5, which is that one. So I'll just press enter. And there's my answer right there. And if I want the other one, I'll do the intersect. Again, first curve blue, second one red. And my guess will be more like maybe 2. I'll guess 2. And my closest 1 to 2 is 2.5 seconds. So,
yeah, that as a teacher, sometimes my students memorize that, like Nintendo, second trace 5, enter, They don't even think about that last enter, but here you have to kind of think about it. You have to put your
Right.
cursor somehow closer to it, either by airing over or like you did. That was pretty nifty just to type in the number there.
Yeah, a lot of people want to arrow over it, get like upset because they keep going,
Yeah.
like that.
Oh, it takes
What
so
a-
long sometimes.
Oh, and something I do want to point out for those using 84, that value of X right there is stored in X. So if you wanted to use that, say, to answer some questions, if you go off to the home screen and type X and you want to use it in value, my suggestion
Oh,
is to
what about
store
Y?
it.
Is Y stored?
And Y is stored also. And so I
Yeah.
can store it into, let's say, alpha G. I use G because G's like nobody likes it. So, and now because as soon as I go back to the graph and do trace and move around, that's now the X value is gone.
Oh, yeah, yeah, yeah.
So when I go here, here's my new X value is here. So, almost pi. All right.
Wow.
So we did that one. A second way would be to use numeric solver. Okay. So Jeff did show this. I'll show this real quickly. Math and up arrow to numeric solver. And looks like I practiced this already. So if there was something here, I would clear it. Now I could type in that whole equation, that whole expression, but it would be so much nicer just to say alpha y1, just put y1 there. And I want to know when that's equal to, what did we say, 500?
Okay.
And now the
Oh,
thing is,
you could solve it here. Okay, so say okay, graph.
So I click on graph for okay. Now here's where a lot of people say, oh, there's the answer. No, that's not the answer. This is you have to give it a seed, I guess, because it could be more than one. So I like to use maybe one for a guess, and you do not press enter. You do not press enter. You do
Yeah.
not press enter. You press graph for solve. And there's that value that we got before.
Oh, yeah.
And if I want to get the other one, I'd maybe go up and guess 10. And then graph, and there's the other solution. So
Yeah,
the
you
solver.
could hit alpha. I think you can hit alpha enter instead of solve if you want to.
Okay, yeah. So
Jesse said that. I thought it was kind of
if I go
nifty comment.
so yeah, there's the green for that.
Because
So
students do
alpha,
want to hit enter. I promise. Students are trying to hit enter. So if you said alpha enter, at least they'd be like, okay, I'll hit alpha enter.
because if I press 6 and press enter, it just says, okay, I'll go with
no,
6.
you don't want that.
Yeah, and that's not the answer. So
Yeah, and the older 84s used to be alpha solve. That was the way. That was the move.
right.
Yeah, Jesse's been teaching a while, I think.
Yes.
Y1 in the solver is a neat thing. Tom, you always, you always impress. I think you just kind of bring it out for the webinars. I mean, this is like you're using Y1 in the solver. You do all kinds of stuff here.
Yeah, but this is what I do during the day when nobody's around too. I just come down here in my basement and just do this stuff and pretend like I have an audience. So it's really fun when there's an audience there.
I know. I've been in your basement. It's not that much fun down there.
Oh, that's right. That's right. You have been down here.
It's just
right.
a lot of Beatles stuff. A lot of Beatles stuff.
There's a lot of Beatles stuff down here.
Yeah.
Right. Okay, so this is a standard question. After how many seconds does it reach its maximum height? So again, I go back to the graph. I think I'm going to get rid of that 500 just so it doesn't, I'll turn it off like Jeff showed me. I just turn off the equal sign there. And then I'll go second trace. And the maximum is number 4. And by the way, when I teach, I don't like to press 4, I like to arrow down and so we can see where I went. Now my left bound is not that number. And again, you could arrow, but I like to go, let's say 2 is the left bound.
Oh, so much better to do that.
And the right bound is like maybe 6. Ooh, that might be too close. I think I goofed. So let me start over again. So second trace, I want to do maximum. So left bound of 2, right bound of 8, guess of something in between 7. And there's my number there. Okay. So there's my maximum. And not only am I getting when it happened, but I'm finding out what that maximum height is. So I'm getting answers for both 5 and 6 at the same time. So we got the maximum height. When does it hit the ocean? Now this is, some kids will say, well, right there. But what happens there, and again, this is something that's not obvious to kids. Jeff, you know what it is. Which one of these things am I going to find in the calculate menu? Which one of these do I want?
The 0, right?
Sure. Yeah, I want to know when the y value is 0, when the height is 0.
Yeah.
And so
Good,
my left
good
bound,
vocabulary.
yeah. So my left bound could be like 8, and my right bound could be like 12, and my guess could be 11. And maybe I didn't go far
Your
enough.
12 wasn't big enough. You keep
Yeah, that's
just
why. There
slightly
you go.
under
There you
charge in
go.
there.
Yeah. Okay. I mean, I would like to tell you I did it on purpose, but I did not. Left bound, let's go with that 10. Right bound, let's go 14. And let's go with 11. And 12 was it. So that's why I didn't get it. It was exactly 12 seconds later. And then finally it says, what is it 1 second before that? And this one's not too hard. You just go at 11, and this is the height at 11 seconds. Okay, 1 second before that. So this is one activity that has lots and lots of stuff in it. Okay. So let me just stop there for a minute and see if there's anything popping up that I should
Tom,
know about.
someone, Jesse just learned the other day. I just know you would appreciate this because I feel like you taught this to me. You can grab a picture from the emulator and drag it into a document, like onto the smartboard or onto a document, I believe.
Right,
Yeah.
right. Just
I mean, you
like
made
that.
that look so easy. You just grabbed it. Where do you grab it?
So what you do is you left click right on the graphs on the screen and drag and pull it off, and you can bring it into, I use Smart Notebook, but it's Word, PowerPoint, other things like that. You just drag and drop, which is beautiful, and then you can resize it. So yes, this is great thing. One of my favorite things to do.
Yeah, and Tom, if you don't want to use the 0 command, there are a lot of teachers out there. In one of the comments, they said like Allison, I think, said she draws the line y = 0 and finds the intersection point.
So we'll go ahead and do that. Second calc, intersect. So first curve, yes. Second curve, yes. Guess, sure. There it is. So yes, thank you for that. Says to you.
Allison gets that, I guess. That's good.
Yeah. So now on the Nspire, let me just show it real quickly on the Nspire because we don't have that many people who used it, but oh no, did I lose it? Oh no, here we go. All right, so ball is thrown. So this is the same problem. This is the activity, okay? So you go to here, this explains the problem, and you go here, and when you get to this, you'll notice there's this little VCR thing for those of you old enough to remember a VCR. So if you click on start animation, you will see what we saw before. The red is the ball going up. The blue is the height versus time. And this one, I had it leave a trail of little dots. And I like that because it kind of shows what you were saying, Jeff, how it's going up slower and coming down faster.
Oh, I do like that.
Okay, so a nice little, and then plot right there. So on this, I also have a couple more of these if you want to play with them, but I also drew a lot of these so that they could do maybe each question on a separate one. So you could say question 1, question 2, question 3, and so on. So so those Nspire people, I didn't forget about you. You definitely are able to use those. All right.
Nice.
So it looks like I'm not going to be able to do what I wanted, but I do want to show you a couple things. And if it's interesting to you, I encourage you to investigate them, but I will supply the student version and the teacher notes and solutions in these slides. So this is my second activity. It looks like I have probably about 3 or 4 minutes. So this comes to me via Gail Burrell. Jeff, you know Gail, right?
I
Former
do.
SCTM president and tremendous presenter and genius. So look at this problem. Solve this problem. When is the absolute value of this raised to this equal to 1? I mean, this is harder than an ACT problem would be, but I think the activity has a lot of good things in it that people should, that would make you want to do this. Okay. So what what we
Well,
need is
that concept of the exponent being 0, that is on the ACT.
all right.
Absolutely.
So there's the 1. That would be the power of 0. Okay. I think that might be the obvious one. But what about if this is 1? If that's 1, that doesn't matter what the power is. So we have to know, when is that 1? When is the exponent 0? And hold on to your horses. When is that -1? Because if it's -1 and you take the absolute value, it's 1 to any power.
Oh my goodness. I
And
didn't
there's
think about that.
one other caveat. If the exponent is 0, this better not be 0 also, or that's undefined. So look at all the analysis that was done that kids should know all in one. Okay.
Oh my goodness.
All right. Now, so what I did was I went through, and I'm just going to show you how I did it real quickly
Oh,
because
look at that graph.
I would like you to see it. So I got the base, I set it equal to 1, and look what happens. I get a quadratic that I don't know how to solve. So this is where I brought in my calculator and put in the quadratic formula that you mentioned before. Okay. And to help me do this quicker for tonight, I did create a program called number 10, because this is number 10 of some problems that I created. Okay. And so number 10 has this in it, but look what I have for in Y9 and Y0. Do those look familiar?
Yeah.
That's the quadratic formula with the equations turned off. So I can now solve any quadratic equation just by having that. I mean, I know some of you have a program and it'll ask you what's A, B, and C and all that stuff. But this, to me, this is the poor person's quadratic formula. Okay. So now that I have this to use it, what I can do is say, well, A is 1. So 1 store alpha A. And since I'm going to put a colon, because I can put more than one command on a line using a colon, 3 store alpha B, and then another colon, and then -6 store alpha C. And so now all 3 of those are there.
Yeah.
And so I'm going to say alpha trace Y9. What it's going to do is going to take the current values of A, B, and C, plug them in there, and give me that answer. And then do alpha trace Y0, and it will give me the other one. And I'm going to show just one more thing. Okay. I wish I could show you more, but I know Mike's probably saying he's never going to shut up and I got to quit. I would like to show you that actually works. So if I go back here, look what I have in Y1. I'm going to go to table ask. Oh, wait, let me go to auto first. And then table ask, and show you that those actually do work. Okay. So notice right now it has this. Okay. Where is that value stored? That 2 point whatever is in Y9, right? Alpha trace. And I'm going to say, put in Y9. Look what we're getting. Alpha trace, put in that number that was in Y0 that we found, and it's making that equation equal to 1. So I know for sure, without a doubt, those values do make that equation equal to 1. Now, I wish I could go on and show you more stuff, but we ran out of time. And I will just tell you that all the materials are there online. I encourage you to use them. Jeff's got some great stuff. Hope you'll think some of my stuff. This one here, this last one, girls to boys problem, it's pretty self-explanatory. And so thank you. I'll turn this back over.
Tom,
Yes.
one more thing. Can you bring up your 84 and go down to Y9 for me? I have to show you something. Just because you showed so many cool tricks, I want to show them this. So go to Y equals.
Oh, okay.
Y equals. Go to Y9. Go down to Y9. Put your cursor after the plus right on the start of the square root.
Right there?
After the plus.
Okay.
And now hit second delete, which is insert.
Okay.
And now do list, like we're gonna do the braces for a list. So second, I think parentheses, I think is the open one.
Okay.
-1, comma 1. And then second close braces. You know what that's
Okay.
gonna do?
Yes, I do.
So
You
isn't that
tell,
cool?
you
You
tell
you
'em.
don't need two
You tell 'em.
equations.
Yeah, you tell them.
It's gonna give you the plus and the minus because you're multiplying by a list of. So if you do y9, I think it gives you both answers now
In braces.
in braces, right? Because you're multiplying by a list. -1, you're adding 1 times that and -1 times that. Sorry, I just had to show that because it was like super fun.
Yes, yes. Okay. So you made us late, so you're in trouble, not me. Okay.
I'm sorry, Mike. Well, Mike's probably already mad at us, so it's okay. It's
I think
okay.
he turned us off. It might just be you and me.
He may.
Right.
We're just gonna keep talking. I mean, we're just gonna keep going here.
Thanks, guys, for everything. I'm going to wrap things up pretty quickly here. Our winner for tonight of the graphing calculator of their choice is William Adams. So, Mr. Adams, I'll be in touch soon to figure out which calculator you'd like to receive. And receiving the certificate of attendance as well as a link for the documents are in the chat window now. And if you're watching this on demand, copy that link into your favorite browser to receive your certificate. And if any of these links are not working for any reason, hang tight, you'll automatically get a follow-up email which will contain all the links you need as well as a link for the recording as well, so you can watch this at your own pace. Huge thanks to Jeff and Tom for everything they shared tonight. The documents are, I think, going to be really helpful as well because I know there's a lot more in there than what you're able to get to everything tonight. So thanks so much for all the time you put into those.
Okay.
And thanks everyone for joining us. We hope to see you back online next week. Have a great night.
Y'all. Thanks.